We are going to determine the density and specific gravity of an unknown mineral specimen. Pause the video as needed to record the data from this experiment. First, we determine the mass of the specimen using a calibrated pan balance. You need to record that mass, which is given in gram units. We are going to use a graduated cylinder filled with slightly colored water to determine the volume. The unknown specimen will be lowered into the water in a cage made of thin wire. The distance between two adjacent lines on the graduated cylinder marks a volume change of 1 milliliter of liquid, equal to 1 cubic centimeter. The volume of water displaced by the wire cage itself is too small to see. The experiment starts with the water level at 80 milliliters. You need to record that initial volume. We immerse the specimen and read the new water level. You need to record that final volume. Subtract the initial volume from the final volume to determine the change in volume due to the submersion of the mineral specimen. This change in volume is essentially the same as the volume of the specimen that we immersed in the water. The density of the unknown specimen is its mass in grams divided by its volume in cubic centimeters. The density of the specimen divided by the density of the water displaced by that specimen is its specific gravity. We are going to assume that the density of the water in this experiment is 1 gram per cubic centimeter. So the numerical value of the density we determined for this specimen is essentially the same as its specific gravity within the limits of our ability to measure these things.